Hello, 8th graders. We are going to be working on a section that we did last year in 7th grade, but I expect that you probably forgot. We're going to take what we did last year, and we're going to kind of take it to a new level. Similar figures, if you remember the project where we went outside and measured the shadow length of a tree, and then we tried to figure out, how tall that tree was, that's what similar figures are. And so we're going to be doing that type of work, except in a more structured environment. So the first thing we have to do is get out our vocab sheet and figure out the vocab for section 5.5. Now, I'm going to tell you right away that cross multiplication is not in chapter 5, but it is something we have to remember. And it's going to always be written as the proportion A over B is equal to C over D. Whoops, this thing is in my way here. C over D. So that means if we have two fractions, like 2 over 4, and I set it equal to another fraction, like 6 over 12, if I did the cross multiplication, and I did 2 times 24, or 2 times 12, which is 24, times 4 times 6, that should always equal 24, which is something that we did before, but now we got to just remember it. Okay, so similar figures, and you can also call them shapes, so similar shapes. Shapes are similar when they have the same shape, but do not have the same size. Alrighty, so that means you're looking at, like, my computer screen is similar to my smartboard. They have the same shape, they're both in rectangles, but they have different sizes, therefore they are similar. And corresponding sides, and this is going to be matching sides of 2 or more figures, meaning like the top side on my smartboard is the top side on my computer, and corresponding angles are going to be matching angles of 2 or more figure. So like the top left angle of my smartboard and the top left angle of my computer screen have to match up. Meaning these two things right here, corresponding angles and sides, mean that we have to make sure that the shapes are drawn the same. Okay, so let's see what that starts to look like when we work through some problems. Okay, in order for shapes to be similar, there are 2 things that need to be true. Number 1, all corresponding angles must be equal. And number 2, and this is where we're going to use a term from back in the day, all corresponding sides must have the same ratio. All right? And what that means is, let's say we draw out 2 little rectangles here, and we'll keep it simple. We'll even draw them as squares. And let's say I've determined that these 2 things are similar to each other. And if this top side is 2, and I go to the bigger figure and I decide that this is 4, meaning it doubles from one to the other, that means if this bottom side here is 3, in order to go from 2 to 4, we have to double. Therefore, to go from 3 to that side, we'd have to double as well. That's what having the same ratio means. And we'd be able to calculate that out by going 4 divided by 2 is equal to, in this case, it would have been x over 3, because we were looking for that. We set up the proportion, and then we just simply solve from there. So it'd be 12 equals 2x, and x equals 6. Many times you'll be able to just see it, and that's totally fine as well. Well, how to write similarity is, if we remember, if we had 2 triangles that were congruent, ABC is congruent to DEF, and I'm just making these up. Okay, we had to remember that A and D had to match up, B and C had to match up, and C and F had to match up. Similar figures are exactly the same, except instead of this symbol, we draw just that middle one. So that Superman cape is by itself. That right there means similar, which by our terminology says that they are the same shape, but not the same size. Okay? And corresponding parts, that is 1 and 2. So if they ever ask you about corresponding parts, okay, that just means they want the first two parts of the definition. Okay? So they want angles have to be equal, and sides have to have the same ratio. Okay? So let's start looking through a couple of these. We have 3 triangles here, and we want to know which 2 of these triangles are similar, and then we have to write a similarity statement. So there's a ton of information here. We have triangle ABC over here, DEF over here, and GHI over here. Now, the first thing we need to look at is angles. And we need to say to ourselves, do any of these triangles have angle measures that match up? So I look at this A here, 33, and I look at this triangle here, and I don't see another angle of 33. I can't solve it, I can't create it. Therefore, without any other work, that triangle is out. It has to match up with every angle first before anything else. Therefore, if it doesn't, you're just done and you can move on. So if I look here, I'm looking at 33 right here. And then I go to this triangle over here, all of a sudden I see, boom, 33. Therefore, I know that A equals H. Those guys match up. Okay, so then I go back over here and I look at 65. And I'm thinking, is there a 65 over here? There is. So C equals I. Those two match up. And finally, I'm looking at, I'm going to extend the page a little bit. I'm looking at the 87, which is B, and I'm hoping that the other one matches up, and boom, it does. So B and G are the same thing. So we have part 1, angles, is done. And if we remember by going back to our definition, we need to figure out that the ratio, if all of the sides have the same ratio. So here's what we do. We know that A and H match up, C and I match up, and B and G match up. So that means that side AC along here has to match up with side HI, because AC and HI have to match up. Therefore, I can write a ratio of 13 over 26, and I can set that equal, and as a fraction, that's 1/2. Okay? So I'm hoping that every other fraction like this with the sides, and I'll write this as AC over HI. I'm hoping that every other side creates that fraction. So if I look down here at BC, that BC has to match up with IG, which is down here. So I'm going to write 7 over 14. And remember, you don't have to write down exactly what I'm writing here. As long as you're getting the important stuff, that's what matters. So I wrote 7 over 14. And I simplify that down to 1/2 because I can divide the top and the bottom by 7. And so we're hoping that that last side, 8 over 16, ends up simplifying down to 1/2. And it does. Therefore, part 2 sides, or I'll frequently write this as the ratio or scale factor, is all the same. Therefore, we have similar triangles. Now we just have to write the system. So I'm going to go just in order I have written here. A, C, B is similar to, that symbol right there, and I write it in the same order, H, I, G. ABC is similar to HIG. That's what that means. Alrighty, if you have any questions on that, be sure to ask me. I'm probably wandering around the classroom right now. I'd love to help you. Okay, so I want you to try this one on your own. I want you to find out if these 2 rectangles are similar to each other, and I have to make a quick change here because I didn't write in the angle. So I'm going to write in 90, 90, 90, and 90. And I want you to tell me if these 2 rectangles are similar to each other. All right, so give it a pause. Alrighty, so we're back. Now this one's interesting. If we look at all these right angles over here, they all equal 90. Therefore, we know the angles all match up. So the only thing that matters to us is the orientation, the short side and long side. So you can match it up multiple ways, but I'm just going to turn this shape around to the right like that. So that means M equals C, D equals N, E equals O, and I'm extend the page down, and L equals F. Or did I write that backwards? Yep, that's fine. L equals F. Alrighty? So this is rotated around. So I need to find the ratios. So I'm going to start here with CF, and I'll go 6 divided by 9. And if I wrote that into my calculator, actually, I'm going to go the opposite way to make it a little bit different. But it doesn't matter which way you went. So I'm going to go 9 divided by 6, okay? It doesn't matter which way you went. I just wanted to go a different way. Okay, so this ends up giving me 1.5. Okay, so then I'm going to go 28.5 over 19. And if I type that into my calculator, which is what I expected you to do here, look at that. It gives us 1.5. And now here's the beauty of this problem, is we actually don't have to continue because it's repeated. The 9 is repeated, and the 6 is repeated, the 28.5 is repeated, and the 19 is repeated. So we're actually done. And we would just have to find a matchup. Now, there's a couple different ways you could write it, but I'm going to write it as C, D, E, F, and that's similar to M, N, O, P. And if you're confused, if you wrote it correctly, by all means ask me and I will come over and help. Okay, so those are similar figures. So let's move on to some story problems. So for this one, it says you want to create a new profile picture on Edmodo. Okay, however, the picture can only be 4 inches tall in your profile. Okay, so up tall is this way, so it can only be 4 inches. But you currently have a picture that's 10 inches wide and 8 inches tall. So it wants to know how wide should our profile picture be. And my solution to these will always be, let's draw a picture. So I'm going to draw my little profile picture here. This is my Edmodo picture. And then I'll draw my bigger picture over here. And this will be my current picture. So my Edmodo picture can only be 4 inches tall. So we're looking right here, 4 inches. And we want to know how wide it should be. So that's our question mark. I'll put an X there. Okay. My real picture then is going to be 10 inches wide. So I'll write that up here, 10 inches. And it's 8 inches tall. There it is. So now we're going to use the fact that we know these two pictures are going to be similar to each other, because all pictures that we have are going to have the same ratio, to be able to solve this problem. So if I know that the height will always match up with the height, I'm going to start on the left side and I'm going to say 4 over 8. Okay, this is going to be the small over the large. And I can set that equal to another fraction for the other side because they're similar figures. So if this is the small here and this is the large, and we also said that this was the height and this was how wide it was, if I write the height over here, 8, and I put it over, sorry, that should be an X. Oh, wait, there you go. Sorry, I made that mistake. It's not wide on the bottom, it's the height for the other one right over there. So this is going to be how wide it is on this side. Sorry about that. Therefore, if I write the height of the small, which is X, because we don't know it, and then we write how wide the larger one is, which we do know, it's 10, I've just created a cross multiplication problem that I can actually solve. Okay, better speed up, we're taking a little bit of time here. Okay, so I do cross multiplication. So I'm going to go 4 times 10 and 8 times X, and I multiply those together. I get 40 equals 8X. I divide by 8 on both sides, and my new X is 5, and I label it as inches. And there it is. This right here is 5 inches. Your picture can be that wide. Alrighty, and that answer makes sense to me. It seems very realistic. So I'm going to have you try your own story problem, pause it and give it a try, and then I'll come back and we'll work on it together. Alrighty, so we're back. Problem says, Salem's creating a new baseball diamond for younger kids, therefore it has to be smaller. But in a normal diamond, there's 90 feet between each base, but 127 feet from home to second. If there's 60 feet between each base and the new diamond, how far will it be from home to second? So I'm going to take my little picture here and I'm going to use these to draw. So here's going to be the large diamond, and here's going to be the new smaller one. And I know that we care about this measurement right there for both of these, so I'll draw that in. And I know that it's going to be 90, 90, and so on around, and this is 127. Then I know for this one, it's going to be 60 and 60 all the way around, and this is what we're trying to find out. So I'm going to label it as Y. So just like I did before, I can create a proportion. So I'm going to say 90 over 60, because these are corresponding sides, 90 over 60, and that's going to be equal to the 127 over my Y. So then I multiply through and I get 90Y is equal to 60 times 127, which I have no idea what that is off the top of my head. 127 times 60. 7,260. 7,260. And then to solve for Y, I just have to divide by 90. So I get Y is equal to 7,260 divided by 90, which is about 85 feet. So there I go. My Y is 85 right there, and that seems like a very realistic answer to me. So, if you have any questions, once again, ask me. Moving on to your problems. It's going to be page 248, 7 through 13. This is going to be seven problems, so you need to get 6 of the 7 right. But, actually, part 12 has a couple parts, so that's actually 10 problems, so you need to get 9 of the 10 right. And the bottom one here is 1 through 6, and then 13 to 14, so that's 8. You would need to get 7 right there. The assignment should be online, and we should have a new program to use. All right, thanks.